Good evening, and thank you all for joining me in our topic of leading Canada against lead. So let's dive straight into it. Water supplies in Canada tend to be really polluted as a result of municipal industrial discharge spills or mishandled runoff. Investment in the water supply infrastructure helps preserve and maintain safe drinking water for all users, but there are significant concerns in the delivery of safe drinking water. A key factor in our poor drinking water supply results from metal. In 2019, an investigation found that hundreds of thousands of Canadians may be consuming drinking water containing high levels of lead. The issue with this is that treated drinking water leaving the plant is being tainted. The nationwide investigation revealed that one-third of all conducted tests exceeded the national safety guidelines. A significant challenge in dealing with lead-tainted water is a lack of national standard and disjointed provincial and municipal quality and testing requirements.
Of lead into drinking water supplies is a very serious issue. When lead is absorbed into the human body, it is stored in bones, tissues, and blood. When exposed to high levels of lead over a short period of time, a person may experience symptoms including abdominal pain, memory loss, kidney or brain damage, and in worst case scenarios can even lead to death. In children, the exposure can be even more profound. Lead exposure can lead to overall reductions in intellectual functioning, affecting academic performance, problem-solving skills. Early life exposure to lead can also increase the risk in later in life mental diseases such as Alzheimer's. Generally, lead exposure is associated with harmful effects on the brain, heart, kidneys, and on reproduction. Acute exposure to lead leads to abdominal pain, nausea, vomiting, diarrhea, and constipation. Symptoms of chronic lead toxicity include tiredness, sleeplessness, irritability, headaches, and joint pain. The contamination of lead in water can also contaminate soil, leading to a significant impact on our food supplies derived from plants and animals. This lead could accumulate in plants and grow to toxic level going unnoticed.
Thank you, Usman. Lynn will discuss how Canada has been handling this issue.
Thank you, Tilak. In Canada, a land with plentiful fresh water supply, it seems that we have also mismanaged our drinking water distribution. To combat this issue, many jurisdictions across the nation are using orthophosphate to reduce the amount of lead leaching into the water supply. This, however, is not without other problems. This will be highlighted later. In this section, we'll highlight some examples of activity that some jurisdictions across Canada have taken, including the province of Ontario, Prince Rupert, BC, Calgary, Alberta, Regina, Saskatchewan, and Toronto, Ontario have done.
Adding on to that, in Calgary, tests have indicated higher than acceptable levels of lead. As of 2020, it is estimated to cost the city over $14 million, with homeowners paying their share over a 15-year period to replace lead pipes. In Regina, sampling results show that 57% homes with lead service lines had water samples with lead levels above the federal limit in the first liter of tap in the morning. Saskatoon has been replacing its lead water pipes in older neighborhoods since 2010. The city covers 60% of the total cost and bills homeowners for the other 40%. Toronto already uses chemicals to reduce bleaching of lead from water pipes, and the amount of lead in drinking water plummeted since. Back to you, Rania.
Thank you, Usman, Lynn, and Deborah. To provide more information on lead and how it gets to the water supply, we turn the team of Lynn May, Ajay Gill, and Ugander.
Thank you, Lynn. When people know that tap water is not safe, they generally tend to depend on bottled drinking water. This gives rise to yet another problem of increased usage of plastic bottles. Let us now discuss some of the environmental impacts associated with this choice. There is a rise in demand of fossil fuels, as these are widely used in manufacturing of plastic bottles. Then there's increased consumption of energy for transportation of these bottles to retail locations. Further, there's this existing concern of rising rates of municipal solid waste, and these plastic bottles are generally disposed of by incineration. So, there's higher emissions of toxic gases into the atmosphere.
Thank you, Ugander. Orthophosphate is a common corrosion inhibitor. It's created by combining phosphoric acid with zinc phosphate and sodium phosphate. Orthophosphate inhibits lead release by forming an insoluble lead phosphate compound. If a controlled amount is added to a water supply, it can significantly reduce the corrosion process of old lead pipes and therefore reduce the contamination. During water treatment, orthophosphate is added to the lead pipes. It then reacts with the lead in the pipes to create a protective mineral-like crust coating. This helps reduce the amount of lead corrosion caused by the pipes. Thank you. Back to you, Rania.
It is clear that all Canadian jurisdictions have a significant problem in providing safe drinking water to the public. Aging infrastructure, lack of consistent agreement in acceptable levels of lead, and a general lack of financial investment to replace lead-lined pipes have led to a patchwork of disjointed programs with varying levels of success. All levels of government must agree on the acceptable levels of lead and strive towards increased transparency of testing of water not only at the source of treatment, but also at homeowners' tap. the impact to an individual's health will profoundly lessen the impact to our health systems. Thanks to our investigative team for providing a compelling analysis and highlighting some of our potential solutions to our case.